Environment promises to become a lot easier for us when alternate sources of energy successfully replace our current pollution-causing fossil fuels.
Steve Rambo's Daily Planet will periodically report on possible alternatives. Tonight, he reports on Brown's gas.
Well, put your thinking caps on, because for most of us, the technical reasons why Brown's gas works are mighty complicated to understand. So we're going to break it down a little bit. Brown's gas begins with water, ends with water. Pretty simple. When it produces a flame, it does so not through explosions like fossil fuel, but through implosions. And here's a definition for a word you'll tossed around. When something is sublimated, in this case, it means it's being directly changed from a solid to a gas. So here goes.
What the professor has done is taking ordinary tap water, separated it into two atomic components, hydrogen and oxygen, and now we have a clean burning fuel that's renewable and reusable, and when you burn it, it goes right back to water. This is a piece of pure tungsten steel, 100% pure tungsten steel, and it takes 6,000 degrees centigrade, close to 5960 to sublimate, which would take approximately 10 times more than what it takes to weld aluminum. Without any adjustment of this flame, I'm holding my finger there, we can sublimate tungsten steel instantly, go right back to gas.
Brown's fuel is also different because the temperature of its flame varies depending on what it's burning. The scientists say the flame temperature is due to an interactive combustion property.
The heat is produced by the material. The tougher the material, the hotter the flame gets or the reaction is.
So what does all this mean? What exactly could Brown's fuel actually do for us?
In the future, with this technology, we will be able to run cars and power plants with clean burning water as a fuel source. And since the Earth is covered with 2/3 water, we will no longer have an energy crisis in this country or in the world, and we'll clean up the environment in the process.
Well, it was worth
Incredible. And finally, an energy source of a different kind.
Today begins one of the biggest weeks for our planet, Earth Week. Each day will be devoted to a different problem affecting our environment. Today is Energy Day, and Earthwatch reporter David Garcia joins us now with a look at what some people are doing for this big week. David.
Okay, Colleen, from love beads and protest demonstrations 20 years ago to pinstripe corporate mainstream. The environment is today's headline, but is it all talk? We're reaching an energy overload with demand and a short circuit on supply. An unlimited energy source, efficient, pollution-free, and it comes from water, even seawater. Impossible, you say. But what you're seeing is a water flame.
We take ordinary tap water, separate it through DC electrolysis into an atomic mixture of hydrogen and oxygen through one hose. And it's a clean, burning, reusable fuel source. It takes nothing from the air, it gives nothing back to the air, and when you burn, you have water as the exhaust, so to speak.
Developed in Australia, turning water into energy is a radical concept for fueling industry, homes, even automobiles. But advocates say it'll take radical ideas to solve the energy crisis.
Now, if everybody used one of these tomorrow for other purposes, we wouldn't have to worry about the ozone layer, we wouldn't have to worry about the emissions from cars or plants. The Earth would heal itself.
All the basic equipment used to manufacture. The Brown's gas welding machine and how it's made and how it works in general terms. This is a metal stamp press which is used to manufacture the basic elements of the cells which create the Brown's gas, which is used as a fuel. Drill, which is used to drill holes at the end of a pipe, a steel pipe, which is used as the basic cell. The cell is within the pipe. How big is the pipe? About 5 inches. Electrolytic disc set. There's a positive and a negative. Okay, and they go together like so. Put together and show it sideways. All right. There you go. And this goes inside the pipe. The complete set with a plastic liner which has been placed around the edge. Now that's the complete unit, and it goes inside the metal pipe. Like so. Quite simple. The two cells which are then welded together using Brown's gas. There are no moving parts at all within the system. BG 4000. It contains 14 double cells. And what is the approximate output of gas?
Yeah, 4,000. About 4,000 liters an hour.
4,000 what an hour? Liters an hour. Okay. Notice the pipes, the plastic pipes there. You see water traveling through the pipes. This is exactly what's happening. All the cells are interconnected, and there's water within each cell. And they're traveling back and forth within another, and it's creating gas. The sound you hear is an electrical transformer converting beat.
It depends, but I would say $15.
Which has got 14 double cells.
$15 an hour.
Contains 6 of the gas cells, the gas production cells, and has an output of up to 35 cubic feet of Brown's gas per hour. So that in comparison to the BG 4000, which has 14 cells, double cells, you're looking at the BG 4000 with an output of approximately up to 80 square feet, or probably cubic feet per hour. Also notice the normal electrodes that are used for arc welding, which are a part of the BG 2000. Also part of the 4000 too. It comes. Basic framework and insides of a BG 1000. It also has, as you can see, 6 double cells. The difference between the BG 1000 and 2000 is in the upper right-hand corner. They do not have a transformer, which is used for arc welding. So if one already has a transformer, you just buy the BG 1000 just for the properties and use of the gas. This is contained within the total 2 sides, with Professor Brown walking around there in the background, of the factory that has the capability of producing 50 units per week, either BG 1000s or 2000s.
What we have here is one cell in the manufacturing of Brown's gas. You see here the water inlet. You fill the whole cell with water from any DC source, being either solar, wind-powered, hydro-powered, battery. You have your positive plates, which are the green. You have your negative plates, which are the red. Dissociation takes place in between. Movement of the molecules then move up to the top, and you see hydrogen and oxygen has become mixed and compressed and is out through the hose, in this instant, to a welding torch. As you can see on the side here, you have heating, air conditioning, fuel for planes, boats, light, cooking, trains, any application which you wish.
Professor Brown to create systems for generating electricity, systems for motors in seagoing vehicles. First of all, you start with water going into a container up in a high area to show by gravity that this particular water will go down the pipe, which starts here. That green, the green tube on the right is nothing more than a water hose filling up the water container. Then this hose here is going to go down into the container that will show the implosion of the Brown's gas.
What we'll do now is open each valve one at a time. Whatever air is trapped inside the cylinder, we will push out through the hoses into this plastic container outside.
The objective is to get all of the air out of the hoses.
That's right.
He's opening up that valve, which is going to be bringing water from up above down into the container, from the container out through each one of the hoses to fill the hoses with water. The reason for the numerous hoses is to enable us to draw a tremendous amount of water through the hoses at one time at the point of implosion. Each valve is being opened to get rid of all the air in the hoses. All of the water is in the hoses. The hoses are full, and what he's going to do now is open up the valve from the gas production machine. That gas is going to then replace all the water within that blue container and the hoses. The purpose for moving all the water out is so that it can be a completely perfect mixture of the Brown's gas within the container to indicate the implosion. So go ahead. Okay, so you're opening up the first. So you've cleared out the first hose. And now he's going to continue to clear out the rest of the hoses. We're going to detonate, point to the unit. We're going to detonate a spark plug, which is going to cause the gas to implode. And please note the area down here where the water is located. I'm going to go down there swiftly so we can see how it works. We're going to detonate it now. You can see how the detonation took place and drew the water up, sucked up into the container. We're going to open up the valve again. By the process, just a moment, by the process of the gas being made by DC energy within these cells, it creates a 60 psi pressure. So what we're going to do is use the gas, which is created in one of the Brown's gas machines, to push the water up 1 atmosphere, which is approximately 10 meters now. So go ahead. That's going to go up and it's going to squirt out. Yeah. Go over there. Okay. It's going to go up here, across inside, and come down over there. Go ahead, open her up. Okay. This shows the pressure of the gas which is being created, pushing all the water out of the container, up that hose. All right, very good. Now, what does all this mean?
What does it mean?
Yeah, I know what it means. I'll explain it. What this means is as follows. This particular unit here could be used as a, call it motor for lack of a better term, on a boat.
Exactly.
Exactly. And first of all, we use the Brown's gas to, as suction, using the implosion process to suck in the water, which from the forward portion of a boat, the water would enter here. We would add more gas then, and a little bit of oxygen, just air, regular air, explode it safely, immediately driving the water which was brought into this container out under high speed, which is totally controllable, out the aft end of the boat. This can be done on a continuous basis and make literally the boat turn into a rocket if the hull can withstand the speed of the water against the hull.
And this is a principle of pull and push.
The principle of pull and push.
Up to now, no one ship was making out high-speed gas, which have only pushed back. And this is pull on the north and push back.
Very good. Using this same mechanism, this unit could draw water up from a reservoir, river, what have you, and from any direction, sucking the water up using the implosion process. In turn, it can push through its regular pressure of the gas which is being generated, it can push the water up another 10 meters. All right. Once that has taken place, oxygen and more of Brown's gas can be entered into the container, ignited safely, again driving the water up to as high as a person would like to put it up. Once it goes into a reservoir in a high area, it can in turn be brought down to generate through a Pelton wheel or some other turbine device energy. Using this process, we're talking about a very, very small amount of energy. Professor, could you come over here for a minute? And we don't know because of the lack of data and research that's been done, but let me ask you a question. If we took 1 liter of water and applied 1 kilowatt of electrical energy to that liter of water, it would create 340 liters of gas. No? What would it create?
1 liter of water and 5 kilowatts of electrical energy.
Yes.
Will give you 1,860 liters of gas.
1,960. 1,860 liters of gas. Okay. Now that gas, if exploded with oxygen a little bit at a time, using 5 kilowatts of energy, it could it push how much water, how high?
I don't know. I didn't explode. I couldn't tell it. I didn't rate this explosion.
Okay.
According to explosion, according to how much air you put inside.
Without exploding it then, using just the implosion process, we know that we can draw it up 1 atmosphere or 10 meters through the implosion, and then in turn, because of the pressure which is being generated just from the creation of the gas by itself, we can push it up another what, 30? Another 30 meters beyond that. But just the implosion and pressure, we can put that up, and that would be about 40 meters for
an implosion and 50 meters.
So the cost there is just a few watts. 5 watts. 5 kilowatts to move
1 liter of water.
Okay.
1,960 liters of water.
1,960 liters of water up 40 meters. Approximately. Okay. And then if you ignited the gas, you blasted it in there. Okay. Very good.
Our body is, the body is instantly melting the hard grade. There is a temperature here which should be about 2,500 Celsius. And that's an instant. Now, this plant creating a different temperature for different elements. If I take an aluminium, this plant is also formed, produced from water, and when it's burned, producing back the water. You can see dripping the water. That show that plant is non-polluted. But one of the most important things, what's very carefully now, that this plant could burn himself and doesn't give it any blisters or any mark or any complication whatsoever. It's not like any other plant which is burning, is coming big, blisters and so on. With the camera here.
It is. I don't believe
and this hot plant, which is filled with the brick, I will put in my hand.
Yes. Jesus.
So you can see that's a deep burning. Burning on this part here.
Yeah, I see.
So that's a 35-degree burning. For such a thing burning is all another ordinary fly. You have to go to the hospital and take it days and days to cure it, that will come into big blisters. But that fly never will give a blisters. It's given to this mark, which tomorrow the mark will completely disappear. And I let you to see it tomorrow.
All right, we'll tape it tomorrow.
All right, to tape it this again to show. Now, why I do that? To show that with this fly, you can use it in the operation table.
Oh, for surgery.
For surgery, instead of laser beam, which is not controllable.
Instead of what?
Laser beam.
Laser beams, which is not controllable.
Controllable like this plant is.
Uh-huh. Okay.
All right. So, that's the first thing. How good is this fly and how reacting on the different element entirely different. Now let's see. I have here aluminum.
Aluminum, yes.
Aluminum. Where's the price? Yeah. That's the price. So first thing, I take it.
Go ahead, Gus. What is this, Gus?
Aluminium welding flux.
Aluminum welding flux. They speak funny in Australia. They can't help it.
Yeah. That's true. Very funny. And I take it. You can watch that I'm not a welder. I try sometimes to do good welding. And I do good welding by life. But he's a welder. He's a specialist to do perfect welding. And this is running like solder. You can see it. Nice. Because even on this side, that is penetrating very, very good. That is the water, and you see the penetration of this. now, we need only to scratch the surface. Coming close.
I am.
Of small implosions, so that not any radiation is going around. And you can see it if I hold the nozzle just here. Second is very, very close. You see, it's about 2-3 millimeter. I hold it as directly to the neck. And I just take it, a piece of brick, and I apply this holding. It's so close. You never could do this with any other plant. This plant is extremely high concentration. Still I got it. Jesus. I wish somebody to do this experiment with oxyhydrogen touch.
600 degrees centigrade.
So yeah, approximately. I will put this tungsten rod. Tungsten rod which melting about 3,600.
Let me zoom in on that one from again right there. Okay. Tungsten electrodes. Okay.
So this tungsten electrode, its melting point 3,900 degrees, approximately
3,900
Celsius. And sublimate.
Sublimate meaning it turns into
on the
vapor.
On the vapor.
Okay.
And sublimate on the 5,960 degrees.
It sublimates at 5,960 degrees Celsius.
Yeah. And now, the sand line without was adjusted, melting the aluminum, aluminum at 600 degrees.
Yes.
I will apply it to tungsten, and you will notice the tungsten instantly sublimate. Instantly sublimate on the 6,000 degree. That is something what you couldn't do with another plant. Maybe you can do a trick with the oxyhydrogen, then introducing much more oxygen, then you don't sublimate the tungsten.
But I noticed that we only have
but
we only have one tube going to that particular unit there. I
That's
understand.
perfect stoichiometric picture. Right, one more. That's refractory brick. It's about 4,500 degrees.
4,500 degrees it takes to sublimate it?
No sublimation to be melt. Yeah.
Go ahead.
To be melt. Okay, now. We'll see what is the reaction of that. Dry.
Again, the sound you hear in the background is that of the unit changing DC to AC. Effectively, the gas is reacting with the mass of the bricks to at a temperature which the brick can melt. This hydrogen gas has no constant temperature. It only reacts to that which is being burned or melted.
So this is a factory brick?
Yes. Using a Australian number 12 head, which is 1.2 millimeters in diameter hole. It's coming from the BG 4000 machine, and also using oxygen to blow the metal away as rapidly as possible. Go ahead. Use this to come up with the cutting filter. Again, it's 1.2 millimeters. Just as clean as you can see. Can you bring that over here a little bit? Right about there. And just hold on a second. Okay. Slowly turn, slowly. Oh, beautiful. Thank you. Oh boy, that's nice. All right. Okay, turn it slowly. Oh man. Back up away a little bit. Right there, beautiful. Okay, turn it around. Okay. A reaction between aluminum and the slag that came off the steel. similar but much more powerful than a thermite reaction. Apparently, Yull, you say that this is impossible with, the only way to do it is with this flame, with Brown's gas.
We have this reaction also with titanium.
You can have this reaction with titanium?
Titanium and what was that, nickel or titanium?
Titanium and aluminum also.
But there was have nickel.
Oh yes, nickel also.
What about titanium?
Aren't you a little close, Yull?
Give you a battery back.
What size tip is that?
Full.
A 12 tip.
1.2 mil.
1.2 mil.
Brazing.
A brazing tip.
Yeah.
Okay. What you're doing is you're heating up the slag first. Melting.
This time I continue the line too. The other reaction is on the back.
Everybody seems to be moving kind of back because they know what's going to go on. Okay, so much for your shirt, Yull. You're putting the aluminum in the slag, in the molten slag. So much for your shirt.
Did you
Well, surprise, surprise. Yeah, I got that. Look at Jesus. Would you please explain what happened, Yull?
You want my shirt?
You ruined your shirt. Brown, and we're at his first research lab facility that he has operated here, what, Professor, for the last 20 years? Last 20 years. And in this particular area within the lab facility, why don't you explain what we have here, Professor?
What we have here is a gas generator, which I built. It's an electric gas generator which is producing hydrogen oxygen mixture. From this gas generator, we have a power supply. Power supply with a lot of instrumentation, which I follow how much kilowatt is going to my gas generator. Then, from this gas generator, we supply gas to this motor, which is modified with special gas.
Now the modification was a LPG modification?
That was taken twice and modified, specially modified for the hydrogen and oxygen. And this gas is taken a long time for modification. But this motor is connected with the dynamometer.
A dynamometer, yeah.
Dynamometer, which dynamometer is measured the brake horsepower.
The brake horsepower.
That's right. The idea was how many kilowatt electrical energy is there, how much gas producing, how much brake horsepower producing with the dynamometer, and how much water, because the exhaust, that's it, the exhaust here, is coming to the condenser. This condenser have the coil, on each coil is run water, that's two tips connected to this condenser. I come in here, which I measure how much water is there. Sorry, I know. The amount of the water, I know. The amount of the electrical energy, I know. The amount of the gas, hydrogen, oxygen, I another brake horsepower, and I'm making what is the efficiency. Because by the field, when you're adjusting the motor, maybe you can create excessive heat. I was calculated a special electronic device, and this electronic device is connected to the shaft. From here is coming to the electronic board, so that's one here, and from the board controlling this fan, which give it...
It's a fan which gives it the equivalent of the speed that the car would be running at, the wind going through there, so you get a better handle on what the cooling capabilities are.
So that I know exactly that's general. Most work was done here. The whole equipment was installed, the room was making special for the motor manometer, this vibration, and special power supply was designed and built.
Now what is this up here, this Krypton triangle?
That's a tuning out for the motor.
A tune-up system for the motor. Okay. And what kind of motor is this motor here?
That's a Holden.
A Holden. Which is is that a Ford or product?
No, Holden.
It's a Holden. That's a 6-cylinder there?
That's 6-cylinder motor.
All right. Okay. Motor. Could you explain a little bit about how the motor worked? Generally, it's like a regular motor, except that the gas that was created went in and imploded, thus pulling up the...
No. It's an ordinary explosion.
Ordinary explosive.
Nothing to do with the implosion. The implosion motor I didn't want to introduce it now, and I want to introduce till I see that people accept it. They don't accept this. The first step, how I can pull in the second step.
Okay.
So that's the idea why I stopped.
Now, was there any possibility for this motor to blow up in the event of an accident?
No.
Generally, can you explain why? It's a regular spark.
Regular sparking. Now I can increase the power, and I can increase it more.
What's the purpose of that?
More. It's a big purpose because the different mixture of the hydrogen is near to different spark, and that is.
What happened? Why didn't the research continue on this?
Because lack of funds.
Lack of funds. And was the government here helpful?
No, at all. No.
Not at all.
Definitely not, because the government here is let you to doing your job, your research. If you make the money, they are partners. They take good tax. Why they should help you? You find somebody else to help you. But they are third partners all the time.
Now you put this, and you did explain to me the engine the other engine that you had running in a vehicle.
Oh, yes.
And what was the reason why that vehicle was not allowed to continue to operate on the road?
It's not completely finished. That was only demonstration in it. Making the short distance, the bottle of the hydrogen. And I'm talking 20 years back. So when the people was know very little about the hydrogen car, hydrogen energy, I was pioneering on that. So, of course, it was very primitive to coming on the road to the market. It wasn't finished. And then, passing to the very best time, that was an investment, and everybody tried to pull down. The company doesn't like it, the gas generator, they have 20 bottles gas to sell. Arabs have plenty of the oil to sell. Who wants the gas generator after 20 years? Nobody at all. And everybody wanted to just something to pour in the car, liquid. That's what the gas. That's the reason why YBG gas doesn't become very popular here.
I've got a question for you. This is we've got this complete facility here. You have this motor, which you can probably be up and operational with, or another one like it, to prove that the concept works like you did previously in a couple of months, because of all the other things that are going on right now. It'll probably take that long. As I understand, this motor has, or this type of concept for this motor has numerous particular uses. You have also other whole different technologies which could be used for boats in the water, for trains, things of this nature. And the whole concept is that it takes a tremendous amount of money for research, that you are curtailed through numerous break-ins, through, for whatever reason, and for lack of money for research, to continue your efforts in this particular vein. You saw, while you were, I'm repeating all this so that everyone will know, while you were working on this, you realized that you could take the gas and use the gas as the flame to be a welding device, and you saw that as a means to make a profit to get in. That's why you're producing welding machines and cutting machines.
Not to hydrogen oxygen, it's interactive with the water. But when the money is finished and generator was on, I kick it out to making more money. So I can put a welding torch and come and get welder and try to sell the welder to raise the money to come back to the motor.
I understand.
So my intention is not a welder. I don't like it that heavy to making this rise.
Okay, very good. You've got this handled.
The scope of the mess defies comprehension. Millions of pounds of radioactive and hazardous waste. The remnants of the witch's brew used to make nuclear weapons at 12 sites in 11 states.
As a people and as a nation, we've begun to deal with some things. We didn't know what we had our hands on. We didn't handle it well. We have a burden to bear.
And the burden is worsened by a tragic irony. The most advanced weapons-producing country in the world only recently began looking at the technology of nuclear waste management.
We can't wait on technology. Therefore, we have to use today's technology, which some people refer to as a hog and haul, which suck, muck, and truck. They're very expensive. When you exhume these waste products out, the problem's not solved. You've still got to take them somewhere. You've got to dispose of them.
So even as the $200 billion 30-year cleanup at the nation's nuclear weapons plants gains momentum, engineers are desperately looking for new ways to handle deadly waste.
This is where we bring in our waste, the bulk liquid.
At the Oak Ridge nuclear weapons plant in Tennessee, the Department of Energy has built the only incinerator in the U.S. which burns so-called mixed waste, hazardous cancer-causing chemicals like PCBs contaminated with uranium, a typical byproduct of weapons production. Liquid mixed waste from the Oak Ridge complex are blended in 10,000-gallon tanks so the incinerator will operate more efficiently. Inside the kiln, waste is burned for as long as 90 minutes at temperatures approaching 1,800 degrees Fahrenheit. The resulting gases then enter a second chamber where the temperature hovers around 2,000 degrees. Engineers say all but negligible amounts of radiation is captured in the remaining...
How's that? Good. All right. Okay, good. We mastered technology here. Professor Brown sends his deepest regrets that he could not be here today. And with his wry sense of humor, he said, but at least, Dan, they'll understand you better than they would me. He is, in this conference, inspired by a brilliant genius from Eastern Europe. It's very appropriate that we consider the work of Yull Brown, too, who was also a genius from Eastern Europe. About a year ago, I might say, he asked me to say that he was detained because machines that he's just importing from China literally arrived yesterday, and he was involved with the customs, and just the logistics didn't work, and he was very sorry that he could not be here. any rate, I want to address the nuclear waste disposal aspect of his flame. You've seen the flame and the amazing things that it does, and I've passed my hand through the flame, and just as you could see, and it doesn't hurt, you don't feel it. One friend of mine said, yes, but it's cooking you inside because it's a different kind of heat. That may be true. Whatever the case, it reacts with materials put in front of it in a way appropriate to the material, which is very curious. I watched the tungsten experiment and was looking to see if there were any drops. Did it melt the tungsten? And there were no drops. It went directly into vapor. At any rate, I want to talk now about the radioactive part. A year ago, last month, former Congressman Berkeley Bedell, at the invitation of writer Christopher Bird, and I should stop just a second there. Christopher Bird expects and intends to be the biographer of Yull Brown, just as he has been for Gaston Nessens. Chris would have been here, except he's presiding over a conference in London at the moment. At any rate, he invited former Congressman Berkeley Bedell, who was beginning known as the father of the Office of Alternative Medicine in the National Institute of Health, to accompany him to California to see a demonstration put on by Yull Brown on nuclear waste disposal. And they went to Southwest Concrete, where one of the machines is in place, and Yull had put on the demonstration, and they had a piece of cobalt-60. He put, I think, some aluminum and steel with it, and then directed his flame, and there was a kind of an explosion like that titanium one. Before the treatment, the Geiger counter reading was 1,000. After the treatment, the Geiger counter reading, same material, which had become sort of a blackened mass, was 40. And given that, Berkeley Bedell then got on the phone and got the Department of Energy to send somebody out, and they came in August 6, 1992 here. 5 observers came down from the San Francisco field office of the Department of Energy. Yull sent a long speech to be read, but we felt it was much better since Hans-Peter Neumann had this video to do it that way, and he did include in it a report which I prepared, which has now just been published in the July 6th bulletin of the Planetary Association for Clean Energy in Ottawa. The Department of Energy watched, 5 people watched the same demonstration, and one of them got so nervous that when he left, he called the State Department of Health and said, there's some dangerous experiments with radioactive materials going on there, you better do something about it. And the Health Sciences, I guess they call it, sent people that very afternoon. And so Yull and his friends at Southwest Concrete repeated the exact same demonstration. And a man named Alex Dong was director of the environmental restoration. No, that's the DOE. There's another gentleman that from the California department that wrote a letter a week later saying that he had seen no radiation readings in the immediate area of the experiment or around the lab. He checked for that. Now, it took 3 months for the Department of Energy to decide what they would say about this very curious demonstration. And anybody who's been in government, around government, knows that if you're in a bureaucracy, you don't suddenly champion something very unusual because your superiors will think you're very weird. And so it wasn't too surprising that they sent back a letter saying they'd seen nothing. And I got hold of that letter. I got hold of the Health Department letter, and this doesn't make sense. They're saying the radiation must have dispersed into the atmosphere. The Health Department saying we checked in the atmosphere that very afternoon, and there were no radiation readings. So that was immediately after a demonstration, not just 3 hours later. So I thought there was some contradiction, and I did a little checking. I put in a call to the Department of Energy people. They called me back, nice young fellows, and they kept me on the phone an hour trying to persuade me that indeed they had seen nothing. And some of their arguments I found very hard to believe. They suggested, one, that the radiation must have been dispersed within, as they called it, the molten matrix, which in other words, that he would have encapsulated the radiation. It would have been sealed within that. Well, I called the official at Southwest Concrete, Bob Zykic, also an Eastern European, that had seen this, and he said, well, he said, I don't think that's the case, because after I read the letter from the DOE, I took the piece of black carbon mass that was left after the experiment, and I took a Geiger counter reading of it, 40. He said, then I smashed it up into ash, into fine particles, so that if there's anything inside there, we'd be able to measure it. And then I measured that again, the same reading, 40. So he said, it can't be encapsulated. Well, basically what I did was combine all of these statements into a little report, and as I say, it's published in this month's issue of the PACE Journal out of Ottawa. And I put my impressions of the DOE people. I figured that it took them 3 months to decide what they'd say, because they knew they couldn't report favorably on something that everybody knows is impossible, or they'd be ridiculed. So it took them 3 months to write their letter. The state health department at least did it quickly. So after talking with them and examining their letter, particularly in the light of the health services, the California Health Services Department letter, and also with talking with the Southwest Concrete man, my observations are that radioactivity was clearly not released into the environment, and radioactivity was not encapsulated. And so by the process of elimination, there's only one thing left of the DOE people's observations. They made the very bizarre statement that he had changed the shape of the cobalt-60, and by changing its shape, he would have somehow eliminated or encapsulated or somehow done something with the radioactivity. I thought that was ridiculous. So at any rate, that was the one thing that they could offer as a possible third alternative to why they didn't see anything. So by the process of elimination, I concluded that in Yull Brown's demonstration to the Department of Energy on August 6, 1992, transmutation of radioactivity material was accomplished, resulting in a drop in Geiger counter readings from 1,000 counts to 40, resulting in a radioactivity waste residue of about 0.4% of the original. And that concludes my observations on the radioactive thing. I think we need to give a great deal of support and encouragement to this marvelous gift to our country from Eastern Europe. I might say just a little, about a half a minute about him. He's one of the most patriotic people to this country that I've ever known, and of course he's from Bulgaria. He was very anti-communist, and the communists put him in jail. They tortured him. They put him in a box where he could not stand up for 5 days. He injured his legs, so he walks with difficulty this day. Well, the old principle that the enemy of my enemy is my friend, because of the tortures of the communists, he became extremely favorable to our country, and it's our privilege that he is with us here. He's just been granted another 3-year visa, so he's here for a while, and he never tires of saying, God bless America, and I think we should say, God bless Yull Brown.
briefly, I'd like to conclude this. I'm sorry, there will be no questions and answers because we've run out of time. But I would just like to say that